Okay, thank you for inviting me for giving this talk about the achievement of Alan. And in doing so, I will try to do a bit of a recollection of about the history of solar GMO detection and how Alan contributed to such detection. I think we can break into three parts the detection of GMOs. First, there was foundation. You stop now, Steph? It was the foundation from 62, from the discovery of solar oscillation, from 76. From 76 to 95, I'll come to that why it's done like that. And from 95 to 2010. From 62 to 76, it was when the field of helioseismology started. And 76 was the foundation for some reason, which was clear at the time. Here I go back to what are the GMODs, as a matter of fact. Here you can see that the GMODs, they are below 500 microhertz, from here to here. And above 500 microhertz, you have the so-called PMODs. And what is interesting in those GMODs is that they have a sensitivity to the core of the sun, which is not the case of the solar PMODs, which are mainly sensitive to the convection zone and the radiative zone. So detecting those GMODs would have been extremely crucial for doing solar physics for the inside of the sun. The problem is that the amplitude of those modes are very small. It's 10 to the minus 4 to 1 centimeters per second, depending on the theory you can believe. And the lifetime is very, very long, 1 to 10 million years. So when the field started, one of the goals was to detect GMODs. And the first claim of detection of GMODs was in 76. This was the so-called foundation, the end of the foundation. This was a paper by Thierry et al. In Nature, which was claiming to have detected solar oscillation at 160 minutes, as a matter of fact, it was. And they used 9 days of data, and here you can see the shape of the oscillation. And it was 160 minutes, discovered by other instruments around the world by using a sodium cell. This was using, it was a differential magnetograph at the time, and also using a potassium cell. So this is when the quest for finding GMODs started. And then we started to have lots of different space missions in the thinking, because since we had so many perturbations on the ground, we thought it was better to go into space in order to detect the GMODs. So here you have lots of different publications around the mid-80s, and the most famous one being the Red Book report, as we call it in ESA at the time. The Red Book report of SOHO, which was approved in 86. So all this work came into a culmination of this SOHO proposal. And this was then what we call the second foundation and Empire. Why the Empire? Because then we had a true GMO detection in 83. It was in Nature again. This was done by Philippe Delache and Phil Scherer. Phil Scherer would become the PI of MDI a few years later. And they were claiming to have detected GMODs. The 160-minute oscillation was never confirmed, and I'll come back to that later. But nor was this detection by Delache and Scherer. So this is when we really started to be interested in having solar GMO detection. So when SOHO got approved, we got different proposals. One was the Hominus, wrong button. The Hominus Golf, the Virgo instrument, the MDI, which was answering the solar oscillation imager on SOHO, and the stable solar analyzer, to which I was contributing at the time. All those instruments were selected, but this one. So this is when I, as a matter of fact, a few months later, this is when I moved to Nordwijk in Estec to join the space science department in order to build an instrument which was part of the Virgo instrument. It was called the LOI. Okay, what was interesting is that the 160-minute oscillation came back on the picture later after this selection of Soho. This was a paper by Ellsworth et al., which shows that this 160-minute oscillation was just an harmonic of the day. It was an nth harmonic of the day, as a matter of fact, and this was just an artifact, and that's why it was discarded. And as a matter of fact, so never discovered or could never see this 160-minute oscillation. Okay, shortly before the launch of Soho, we thought that we had the end of our G-mode quest, because some people were claiming in Nature again that the G-modes were detected in 95. This was done in using solar wind data in the interplanetary medium. It was done by Thomson, I can't read it, Thomson and at least Lanzarote, and I think it's McLemon. And they were using something which was interesting at the time. They were using the fact that they were applying a technique used in a patent used for detecting frequencies in mobile telephones. But the sun is not a mobile telephone, as far as I can see. So the technique they were using was simple. They were just trying to detect frequency at given frequencies. And of course, it works when you know the frequency you want to detect. But if you know the frequency in advance, then you're not detecting anything, because you're just narrowing your search on what you want to detect. So I did some fun exercise with Thomson at the time, which was to give him a spectrum in which I have put some frequencies. And as a matter of fact, Thomson was indeed detecting the frequencies after I gave him the frequencies. So it was clearly a non-working algorithm that he had. So after all, since I was in ESTEC, I was frequently seeing this Englishman in my office, because he was attending this science working team to which he was PI of an instrument. It was golf. And this is when I met Alan in those days, when I was working in ESTEC. And here you can see then the same picture as Patrick showed. And this is the location of the golf instrument on the spacecraft, right here. And here this is the MDI instrument. Okay, then we had the launch of Soho on December 2, 1995. That was a great adventure. And then we could start to look for the G-modes finally. So here I want to go back to one of the golf spectrums that was showed by Patrick. I think you showed some such spectrum, did you? It was an MDI one. Well, shame on you then. So this is a golf spectrum as measured by in 88 or so. And this is here in blue. This is the background as measured by Ellsworth et al. From the ground, showing clearly that you can very closely get the limiting factor due to the atmospheric effect. So you can remove the atmosphere and then try to get the limiting spectrum. But what was interesting, I have done also some measurement in 83, and this was my first paper here in Meudon. And I was also measuring the background. And funny enough, this background I measured was exactly the same as Ellsworth et al., something like 11 years before. So when you are a graduate student, you think that what you're doing is bullshit. And in retrospect, it was not so much bullshit after all. All right. Then one of the aims of the golf instrument was to detect G-modes. And one of the main contributions of Alan was to start to focus on different techniques for detecting. For detecting G-modes. what he wanted to do was to use single spectrum and average spectra, and also to use oversampling, and especially by doing zero padding. We had a great deal of work trying to understand how the zero padding would affect the statistical behavior of the power spectrum. And then one thing which is also one of my pet projects is understanding of noise and the statistic of signal. And in this paper of Gabriel et al. 202, I brought the fact that we had to use the H0 and H1 hypothesis. And using this, all those toolbox, we could at least try to have what we call the candidate. It was at 284 microhertz or so. And now I don't remember whether it was a G mode or a P mode, but I think it was a G mode, Alan. Sorry? So this spike here, which is above this 10% detection limit, was thought to be a G mode, but it has not yet been confirmed. So that was what I call the secular view. But from the Gulf project, there was also the faithful view. It was detection techniques used by Turchez et al. In 2004, and at the time they were using frequency above 150 microhertz. And they were looking for frequencies within 10 microhertz of theoretical ones and looking for multiplets. They typically use a frequentist approach, and they try to follow the evolution of what they call the candidates. There was a list given in this paper, but since then, I think this has not yet been confirmed either. And how much I have left now? -1 minute, Mr. Chairman? -2 minutes, okay. All right, then came what we call the Phoebus group. Yeah, if you want to know about why it's called the Phoebus group, you have to talk to me offline because I don't have time to go into that. Right? The Phoebus group was a gang of scientists from Virgo, India, and Bison that were trying to get the G modes from different set of instruments. And I know it took some time in order to have the Gulf personnel involved, and I had almost to fight with Alan trying to put them aboard. But then when I came back to France in 2004, I managed to put them aboard, and then they were contributing to the team. As you can see here, this is Alan here. So. And Alan as well here. So we had some interesting work done in Bern at EC. And then we were still trying to find the G mode. This was back in 2007, I believe. Okay, in 2007, Garcia et al. From the Gulf team published a paper in Science using the collective detection, using the collective behavior of G modes, because the G modes they are repeating their periods in the period diagram, and then when you take a Fourier transform of the period diagram, you can get a spike which is just gives the value of what's called P naught. And they were claiming to detect such a signature from a collective signature of the G modes. And then they also tried in 2010, to get individual G modes. And here this is from the Virgo instrument. And just for fun, I took my 17 years of LOI data, and I superimposed the same diagram as done by Garcia et al. And as you can see, they were claiming that this could be a G mode, but it's a bit offset from the theoretical frequency. But funny enough, I have one which is very close to that frequency. So I wonder, should I believe what I've done, or should I believe what they've done? I don't know. It's for you to ponder. Okay, one of the achievements of the Phoebus group was to publish a non-detection paper, where we said put the upper limit of the G modes, and also we put we had a review paper in which we had no firm confirmation of detection or non-detection, And it took several weeks in order to arrive at the consensus on this sentence that you cannot read maybe from the back. There is currently no undisputed detection of solar G-modes, which means that if one detects G-modes, we are still fighting over it. All right, I'm almost finished. I have 2 slides, if the chairman, Mr. Chairman, will allow me.
You don't have a choice.
You have no choice anyway. Right. So this is what we got. It's a zoo of theoretical G-mode amplitude. The G-mode amplitude goes from Belkacem et al. From roughly 1 centimeters per second as for the highest theoretical limit, to something like 10 to the minus 4 centimeters per second. So you see the broad range, which shows the sheer uncertainty in G-mode theoretical amplitudes. And here you see the limit set in blue here by the Gulf in 17 years. And I think that if we would have had this highest amplitude, we would have detected the G-modes by then. So I guess that it's very likely that the next theoretical G-modes amplitude could be as close as this one, or in between those two. So I think we have not yet really detected the G-mode as far as I'm concerned. It's still a quest to be reached. So I will conclude. Maybe we are in the realm of the third foundation. I know it doesn't exist in the Isaac Asimov trilogy. It's called something else, but I think it would be more interesting to call that third foundation. And then I'm almost finished, and I would like to thank Alan for all he has allowed me to do. First, he allowed me to return to my home country. I don't think you remember that chat we had in Warsaw in 2000? Oh, yes. I remember. All right. And also, thank you for allowing us, the Phoebus group, to pursue the G-mode quest. I know it took some time to have Golf part of Phoebus, but finally we had a Golf part of the Phoebus group. And also, last but not least, thanks for allowing me to realize which field of science was really mine. It's helioseismology. And I thank him for that. And finally, we will be doing the filter graph of phi. Thank you.